Today we're going to talk about three different kinds of interest formulas. There's simple interest, compound interest, and continuously compounding interest. And really the concepts really are not that intense. What makes them tricky is just knowing when to use which formula. So at the end of the day, you're just taking a bunch of numbers, plugging them in, and running some calculations with your calculator. But knowing which formula to use is really what I want you to take away the most. So I'll be talking about that as we go. But let's start off with simple interest. Basically what that is it's interest that is paid only on the principal during a period of time. So if you deposit $100, you're going to get interest off of that $100 and only off of that $100. So as time goes on, you're still getting that same amount of interest. Let's say you get $10 interest. You'll keep getting $10 interest year after year or however long you have this thing. The principal is P in our formula, and it's borrowed for some T amount of time and at a rate R. The interest, just the interest that you have is given by this formula. So I is going to equal P times R times T. So note that the rate will be a percentage as a decimal. Notice that this is a linear equation. So T is like my X value, I is like my Y. The interest is going to accrue linearly, so not exponentially like most interests from banks, things like that. So why don't you try and use this formula in this problem here. This should be on your packet. You should read it out, see what kind of important information there is, put it in the right spot in the formula, and see if you get the right answer. So why don't you pause it here and do this problem, and then resume it when you're ready, and I'll show you the answer. All right, so here's what I got. I plugged in 2500 for P, 0.03 for the 3% rate, and then 0.5 for time. So the reason why I did that is, if you saw here, the CD lasted 6 months, and the percentage rate is a yearly rate. So if the amount of time, it would be in terms of years. Half a year, that's how much interest I get. So how much do I actually have? I have whatever the original was, plus whatever the interest is, and that 2,537.50 cents is my total. That's simple interest. Compound interest is a little bit more complex, and really what's going on with compound interest is you get the benefit of receiving the interest not just off of your principal, but also off of whatever interest you've already gained. So I'm going to show you two separate types of compounding interest problems. The first time, what I'm going to keep the same between both of these different interest problems is the principal, the rate, and the amount of time that you have this. Let's pretend that this is a savings account, and you put in $100, and you get a savings rate of 8% per year. So if we were going to compound this thing annually, basically what that means is that your interest is calculated at the end of the year. So we put in our money in January 1st. We deposit $100. The whole year goes by, and we get 8%, and our bank account grows, and hey, what do you know? We got a final amount of $108 in our bank account. So it's compounding annually, just one time at the end of the year. So we're going to compare that with compounding quarterly. Now again, we're going to keep everything the same. We're going to have the same principal, same rate, same amount of time, 1 year. But what we're going to do is, if we're compounding quarterly, that means that after every quarter or every 3 months in the year, we're going to calculate whatever interest has been accrued at that point. And we're going to calculate interest off of not just the original amount you deposited, but whatever is in your bank account at that time. So I'm going to take that same 8%, but now I'm going to kind of chop it up into 4 bits. And if I spread that 8% out over the year, it's kind of like I'm getting 2% 4 times. So what I'm going to do here is I'm still going to deposit that same amount, that $100. And after the first quarter, it's going to grow just a little bit. And the way I find that out is I'm going to basically just multiply the $100 times 1.02 for an increase of 2%. And now I have $102 in my bank account. So March 31st hits and interest has been accrued. I've got now $102 in my bank account. So that's fine and dandy. And then another few months will pass, and we're going to add another 2% of that compounded interest in here. And so basically what I'm doing here is I'm taking whatever I had the last month, which is 100 times 1.02, and I want to add another 2%. So I'm going to multiply this by another 1.02. And so now in my bank account I have $104.04. Now if it looks a little bit annoying or complex at the bottom there with lots of multiplication, we know that we can rewrite this in a simpler way as 100 times 1.02 squared. So that's basically what I get after I've compounded twice so far this year with a 2% little mini rate each time I'm compounding. So we're just going to keep doing the same thing. We're going to compound again, and we're going to grow a little bit more. We're going to take that amount that we just had in our bank account, and we're going to multiply that by another 1.02. That's going to give us $106.12. And again, we can kind of simplify at the bottom there, make that just a 100 times 1.02 to the third power. And then we've got one more time to compound this thing. It is quarterly, so we need to hit that fourth quarter. And we're going to, once again, compound whatever we have in our bank account by multiplying the current amount by another 1.02 to get that final 2%. And what do you know? We have $108.24. So this is another way of writing that is that 100 times 1.02 to the fourth power. So now it turns out that I'm actually getting 24 cents more even though I use the same rate and the same principal in the same amount of time. Really what I'm doing is I'm benefiting from multiple calculations or compounding that interest multiple times is what we would say. So we like compounding more. Let's take a look at where that comes from. We're going to kind of get towards a compound interest formula. So this is kind of like my final equation that I got that would produce that final $108.24. I took that 102 or 1.02 and I basically multiplied it by 100 4 different times. And so let's kind of figure out where the formula is hidden inside of this. I can kind of restructure this equation by kind of separating the 1 from the 0.02. That's like my 2%. Let's think about where did 2% come from? Well, it came from taking the 8% and chopping it up into 4 equal parts. So I'm just going to kind of rewrite this formula by taking my original 8%, but I'm going to divide it by 4. And that's where that 2 came from. Now one thing that I want you to notice here is that that 4 shows up twice. That's not a coincidence. That is the number of times that we've compounded it each year. So we have an exponent of 4 because I multiplied 1.02 by this 100 4 different times. And then I'm dividing it by 4 because I'm taking that, whatever that rate was, and chopping it up into that number of parts. Now if I wanted to, let's say I wanted to run this for a second year, really what I'd be doing is this whole 1.02 another 4 times. So, it's kind of like saying raising all that mess to the 8th power. If I wanted to go 3 years, I'd be just adding another 4 of these 1.02s to be multiplied together there, and that's like to the 12th power. Or I can kind of abstract this a little bit further and just say I can multiply 4 times 2 if I want 2 years, or times 3 if I want 3 years. Now we see kind of a formula emerging. The general formula for compound interest is this right here, where P is the principal, R is the rate, T is still the time, but now we have this new value, this new constant N, and that stands for the number of times that you are compounding per year. So in this case, we had a 4 in there since we were compounding quarterly. But you could compound monthly and have an N of 12. You can compound weekly, have an N of 52. Or semi-annually with an N of 2, or whatever you want, daily 365. And that's just going to change whatever these N values are. So what I want you to see from this is that the more times you compound, the actual more interest you will receive. A good question comes to mind, like, does that ever stop? Can you continue to get more and more and more and more and more? Or does it kind of reach a ceiling? Well, before we find that out, I want you to try this problem here. So here's a compound interest problem, and this should be in your packet as well. So find the given information, take what's important, put it into the formula, and see what you come out with. Why don't you pause the video, do this problem, and then resume when you're ready to see the answer. Okay, so this is what I'm coming out with here after I plug in all these values, the 3,000 for the P, 0.03 for the rate. Quarterly, it's compounded quarterly, so I put in a 4 for my ends, and 7 years gives me a T of 7. So I get $3,698.14. So the question begs itself, does this ever reach a limit, or does it ever stop getting bigger and bigger and bigger if we compound it more and more and more? And this is what I want you to figure out. So what I'm going to have you do is I'm going to have you pause the video and actually go through this table. If you take a look on the next page of your packet, this table is right there waiting for you. And the only thing that stays the same for all of these different scenarios is you're putting $1 in, and you're getting an interest of 100%. So that's the same no matter what. What's going to change is the number of times that you're compounding this stuff. So I want you to see what happens when you compound annually, when you compound semi-annually, quarterly, monthly, daily, twice daily, 3 times a day, and so on and so forth until you reach each second. So you're going to figure out what that n should be, use the n for that formula, same rate, same principle, and I want you to see what the balance would be after a year. This will take you about 10 minutes or so. So make sure you pause this video, work with a buddy, and see what kind of values you get. Okay, here is a table of what your values should have been when you did these calculations. So you can check what you have here and make sure you got the right values. And what I want you to see is that we're actually kind of approaching a limit here. We're not really getting above this $2.7172 mark. So I can take this and really jack this thing up to a large number, but we're kind of not really getting much higher than this. So we're really, once we keep going, we're only changing these decimals after our cents are way passed over. So really the most that you can get from any sort of regular 100% interest rate, no matter how many times it's compounded, is kind of like this 2.7182 or $2.72 about. And this number is actually really significant. This number is called the number E. And this is kind of like pi. It's kind of like one of those fancy irrational numbers that has a lot of mathematical significance. And this number is really important because it kind of helps us calculate what continuous compound interest is. So here's the third type of interest formula. If you were to compound your interest continuously, meaning you're not waiting at the end of the month or at the end of the day or even at the end of the hour, but constantly, continuously compounding every moment, every moment, every moment, you can use this formula here. So the amount that you have at the end of any time t years is given by this A equals P times the number E raised to the RT power. So we remember this as PERT. It's a great formula, great for your hair, great for your money. It's wonderful. So you can actually use this formula using the number E. And you don't have to memorize any digits of E. It's actually right on your calculator. So if you take a look at your calculator, you should see a button that says LN. It's on the left-hand side, and it's close towards the bottom. If you press second and then that button, you'll actually bring up the number E raised to kind of a blank exponent. So you can use that button to help you solve these continuously compounding interest problems here. So if we wanted to find out how much money is in some bank account using continuous compound interest, we're going to just plug stuff into the formula. Here's another example. Why don't you give this one a shot, pause the video, and then come back when you are ready. Okay, so what we're getting once we plug all this stuff in is we are getting about $6,356.25. So really all I'm doing is I'm multiplying 5,000 times the number E raised to the 0.06 times 4 power. So again, you could plug all this into your calculator using that second LN button. This is compounding interest, but the difference is that you are continuously compounding. So as far as when to use which of those three formulas, simple interest, you're looking for the words simple interest in your problems. Anything that is compounding quarterly, daily, annually, basically anything that is compounding not continuously, you're going to use the formula from back here, the compound interest formula. Whoops, I went too fast. Anything that says that you are continuously compounding, that's the only time you're going to use this PE to the RT. So I want to make that distinction because if you're compounding quarterly or annually or semi-annually, don't use this formula on the screen. You have to use the other compound interest formula. So you should be ready to get some practice on the homework. If you jump to that last page, numbers 8 through 17, that kind of gets you started right away on these compound interest problems. So give those a shot. I'll have all the answers posted on our classroom page. So good luck. Let me know if you have any questions, and I'll see you soon.